Okay.
Spread every time.
Okay, differential equations, growth and decay formulas. So we're going to start today just by solving differential equations. So I'm just kind of jump into an example. So y prime equals dx, 2x over y. So that's our original equation. We can also write y prime, remember, equals dy over dx. Same thing. So we need to get rid of, we need the y's on one side and the x's on the other. Got it? Mm-hmm. Okay. So we are going to, I'm going to do it a little bit different than the book would do. I'm going to rewrite this as dy over dx, first of all, because I think it's easier to think about it to start out. So I'm going to have to multiply by y on both sides. And I'm going to have to multiply by dx on both sides. Again, to get the x's and y's on opposite sides. See what I'm doing?
Yeah.
Okay, so on the left, the dx's reduce. On the right, the y's reduce. So I have y dy equals 2x dx. Following what's going on? Okay, so I need to get rid of a derivative. So how do you undo a derivative? Integrate. So I'm going to integrate both sides. Now on the left, we're integrating with respect to y, and on the right, we're integrating with respect to x. So we have y, so that would be what, 1/2 y squared? About 1/2. Equals, and technically it's plus c, yes? Mm-hmm. Okay, we're not always going to do this, and I'm going to show you what happens to it. And on the right, what do we got? 2/3? Nope. 2 over 2 would be 1, so x squared plus c. And this c, we're going to call it c1 and c2. But those are just constants, correct? So I obviously want constants on one side of the equation, don't I?
Yeah.
Okay. So I'm going to move my x's on one side and my y's on another. To get a general solution, we're going to have it xy on one side and the constant on the other. So I'm going to subtract c1 over, but it's still just going to give me a c, isn't it?
Yep.
And I'm going to subtract x squared. So, I'm going to go the other way. Can I go the other way? Oh, never mind. I'll do it. Because I think you guys would probably do it this way. Okay, so I have negative x squared plus 1/2 y squared equals just a c.
Because we don't know what it is.
We don't know what it is. Okay. Now, this is a general solution, but we have some things we need to fix. First of all, we shouldn't have a negative x, should we? Nope. And we should not have a fraction. So what do I need to multiply everything by to get the x to be positive and this 1/2 to be a whole number? Negative 2. So I'm going to multiply both sides by negative 2. Now on the right, I'm still just going to have c.
Right.
Because the constant times a constant is still a constant. On the right, on the left-hand side, I'm going to have x squared minus, how about 2x squared minus y squared? I do not know why it's spaced out so much. That's weird, isn't it? So 2x squared minus y squared. Make sense?
Yes. Mm-hmm.
Not too hard, is it? I don't think so. So the equation's going to get a little bit more involved. Yes. That's basically it for today's assignment. We'll work a couple. Your assignment is page 420. So we're in chapter 6, correct?
We're, yeah, 6 points.
6.2, page 420, 1 through 10. And I will get that posted. I just didn't, like I said, I was late. I had an appointment this morning, so your board isn't up or anything.
It's okay. I came up here to hang out with you, and you weren't here.
I know. Sorry.
Yeah.
Okay. So wait, I know you all love this because I do them out of order, right? Did you get it written down?
Yes.
Okay. So let's do 4. Does that sound?
I'm not ready yet. Sorry, I'm still. So
420.
1 through 10.
Yep. Okay. So 4 is dy dx equals 6 minus y.
Wait, what was the assignment? Was it 1 through 10 or 4 through 10?
1 through 10. I'm just skipping.
Okay.
I figured we'd do 2
Okay.
together. Okay, so it's already written dy dx. Some of them are dy dx, some of them are y prime. If it was me, just right when I wrote it down on my paper, I just put dy dx.
Right.
It's easier to think about. Okay. So I need to move dy is on one side, dx is on the other. I would
Multiply the
assume
other side by dx.
what?
Multiply the other side by dx.
And divide. So multiply over the dx, but also divide because this is one quantity, right?
Yes.
So it's going to be dx times that. So I'm going to have to divide by 6 minus y.
Yes.
So I'm going to have dy. Actually, I'm going to have 1 over 6 minus y dy. Because I don't want to put it over it. That would bug me. How about you? Would that bug you guys? Okay, so I've got the x's on one side, the y's on one. And like I said, some are going to take more than others to do that. So now I'm ready to get rid of my derivatives. So I integrate both sides. So I'm assuming you want to do the right-hand side first. Okay, so I personally just would write x plus c on the right-hand side. I only ever put my c's on the right-hand side because I can extend it. Does that make sense? I don't even put the c's on the left. No point. Okay, so with 1 over 6 minus y, probably going to need to do a u du type situation, right? Okay, so u is what?
6 minus y.
6 minus y. And y, or u prime is negative 1 dy, right? So the only thing we're missing is a negative,
Yes.
correct? So it's going to be negative. But what rule is this going to apply for, guys? We have u prime over u.
It's one of our 3 special.
It's one of your special ones, right? Got your derivatives or your integral sheet.
Yeah.
Which one gives me u prime over u?
That would be basis other than e rule. No. Natural log.
It'd be natural log, wouldn't it?
Yeah.
Okay, so we're going to have the natural log of the absolute value of u, right?
Mm-hmm.
So 6 minus y.
Mm-hmm.
Okay. So I personally, on my whole assignment, and I think the book was too, they were setting it equal to y. And can I backtrack over here?
Sure.
Which I should have done. Okay, this is in standard form right here. right? Oh, you can't see. So this is in standard form, which isn't really good for anything but looking pretty, right?
Like me.
Yeah. But you're good for more than just looking pretty. So if I took this right here and I bring this C over and leave the X alone, so I have 1/2 y squared equals x squared plus C, like that, okay? I need to multiply by the reciprocal of this, don't I?
Uh-huh.
So I need to multiply everything by 2.
Yes.
So I get y squared equals 2x squared plus C.
Yes.
And I need to take the what?
Derivative.
Not derivative.
Square root.
Square root. So y equals the square root of 2x squared plus C.
Right. Yes.
Makes sense? So we will probably put it in y equals form. That makes more sense because I can graph this, correct? I can do a lot of stuff with this. Where standard form, again, nothing but just looked pretty standard form to me. Okay, so we want to solve this for y.
Right.
So the first thing we want to, and these are absolute values here, not ones. So the first thing we need to get rid of is what?
Your x.
How about
Your natural log. Your negative.
my negative? Yes?
Yes.
So then I have the natural log of 6 minus y, absolute value, is negative x minus c, but still just what?
C.
Plus c. We're not even going to change it to a minus. So I need to get y equals when I'm done. So how do I get things out of a natural log? I change it to what form?
Get it in.
Logarithmic to
I,
Sadie. Logarithmic to, what's the inverse of a log function?
it would be the.
Exponential.
Yeah.
Okay, what's the base for natural log?
E.
E. So it's e to the negative x plus c equals 6 minus y. Okay, I'm looking for y equals again still.
Then you can manipulate that by adding y over. Or subtracting 6.
Let's just subtract 6. So when I subtract 6, I subtract it from the c, and I still get what?
C.
C.
Yes, yeah.
So I get e to the negative x. Oh, that plus c, never mind. No. Where's that plus c supposed to be? Isn't it supposed to be in the exponent?
Yeah.
Yep. Sorry. That's why we have to make them look like exponents, right?
Yeah.
Equals y. Oh, negative y. Now I need to multiply both by a negative. So I have y equals negative e to the negative x plus c minus, plus 6, right? Now, that's all well and good, but do we really want to see in an exponent?
Not really.
No, not really. Okay, so we need to deal with that. So when I'm adding exponents, I'm really multiplying, correct?
Yes.
Okay, so I have negative e to the x times e to the c plus 6.
Right.
Well, e to the c is a what?
Constant.
Constant. So this right here is c. Well, it's c times e to the x. So we have y equals negative c e to the x plus 6. Okay, the reason I did this is because if you look at when you look at it, 3 is almost exactly the same. Okay, so we were done. Of all these steps, we were done with the calculus here. 3 steps to calc. Actually 2, right? All this was just manipulation of the function to make it look nice and pretty.
Yep.
Look at that. How exciting, right? Okay. I'll let you guys pick the next one. Zoom in on you.
Okay.
Which one looks fun?
Maybe. I don't know, 6. What do you think, Sadie? Okay.
6? Okay. Okay, 6. So I'm going to change y prime right away to dy dx. And then square root of x over 7y. Now, again, guys, you're going to only have 8 problems. I want you to try every single one, okay? If we manipulate them wrong, then we manipulate them wrong, and we'll go from where you're at, okay? So, first thing we do is what?
Get the. Integral.
Nope.
No. Get x's and y's in different sides.
X and y's in different sides. So I'm going to multiply the left by 7y and the right by dx. So I have 7y dy equals, I'm going to do x to the 1/2. Why did I change it to x to the 1/2?
Because it's easier to deal with exponents.
Right. So now I'm going to do what with both sides? Integrate it. Okay, what's my left going to be?
7. No. Goodness. It's going to be 7y to the 6.
What?
I don't.
There's a 1 right here, yes?
Yeah.
What's 1 plus 1?
2.
2. So 7/2
Yeah.
y squared. Did you just forget how to integrate?
I did, yeah.
Okay. So 1/2 plus 1 is?
3/2.
And so it's going to be 2/3.
Yes.
X to the 3/2 plus c. So now what?
Then you can make it y equals.
Yep. How?
You can. Wait a minute.
You're on the
You
right.
need to get the square.
Well, we need to get rid of the 7/2 first.
So you divide everything by 7/2.
Or multiply by
the reciprocal.
right.
2/7.
So I'm going to multiply everything by,
The reciprocal.
so 2/7. So I get y squared equals 4/21. Is that right? X to the 3/2 and just plus what again?
See?
C. Because again, C times 2/7 is still just
A constant.
a constant. Okay, now how am I going to get rid of the 1/2?
Square root. Of
Square root. Or I'm going to look at it a little bit differently. The last time I wrote square root, but could I just take it to the 1/2 power?
Yes.
Okay, so if I do 1/2 power, because I already have a fractional exponent, don't I?
Yeah.
So probably 1/2 power would be the easier one.
Yeah.
So I take this whole thing. To the 1/2 power. Now I wanted to do something that I really shouldn't do. Did either of you tell me what I really wanted to do right there?
You really want to. Nope.
Nope.
Really wanna.
Okay. My brain really wanted to distribute that 1/2 power. Can I do that? Can I do that? Nope. I cannot do that across a quantity, can I?
Nope.
So my answer is either y equals the square root of 4/21 x to the 3/2, which looks kind of funny, plus c, correct?
Correct.
Or y equals 4/21 x to the 3/2 plus c all to the half. Personally, I would rather look at this because then I have two fractional, right?
Yes.
In the textbook, if you look up the answer on this one, they put this one in standard form. And I think it's because they think it might look better than this. Does that make sense?
Yes.
So if I'm going from standard form, it'd be back here. And I would subtract, actually, I would subtract my y over and my c this way.
Mm-hmm.
So I would have c equals 2/3 x to the 3/2 minus 7/2 y squared. When I'm there, though, I probably should get rid of my, where did I put 3/2? That should be 4/21, shouldn't it?
Yeah.
Okay. When I'm here, should I get rid of my fractions? Yes?
Yep.
Now, here's the fun part.
We're not done.
We're not done. That's silly. I would need to multiply everything. Well, the only way I'm going to get rid of 21 is to multiply 21.
Right.
And the only way I'm going to get rid of 2 is multiply by 2. So 2 times 21 is 40, 42. No, I'm just showing you.
No.
Okay, so 21 goes into 42 how many times? Twice. So 2 times 4 is 8. X to the 3/2 minus 2 goes into 42 21 times.
Yes.
So 7 times 21 is 147. Look at that. That was exciting, wasn't it?
Sure.
Oh, wait, that's wrong. This was 3/2, wasn't it? This came when I did what with it?
When you
Multiplied by the 2/7. So this was 2/3. I messed up. Sorry, guys. So this would just be 6, wouldn't it?
Mm-hmm.
So that's gonna be nicer, isn't it?
Yes.
So 6 would be 2. 2 and 4. 2 and 2 would be 4. And this would be 3, and this would be 21. Oh, that's better. If I looked at the right spot. But I'm okay with this. I'm just telling you, in the book, when they get nasty looking like this, they tend to put them in standard notation. But it's not wrong. Okay?
Okay.
That's all I got for you.